Hello students, this is Dr. Visanarazu from IRE. Today we are going to discuss problems on module 2 in analog and digital communication course. Okay, in analog and digital communication course we are going to solve the problems in module 2. So what is module 2? It is angle modulation. So in angle modulation we are having a phase and frequency modulation. So, but the syllabus mostly covered on frequency modulation. So, here the problems which is going to solve on frequency modulation. Okay. So, coming to the second module in analog and digital communications. So, what the CO2 states? Interpret the generation detection techniques of frequency modulated waves used for audio signal transmission systems. So this is the course outcome for the second module. Okay. So here we can see the generation detection techniques of frequency modulated waves. So FM signals. Okay. So already we know that in analog and digital communication question bank consists of 3 parts. Part A is the problem solving and critical thinking questions. So here the problems are on critical thinking. That means you are going to apply the formulas and finding the different problems. You are getting different values. Okay. And part B consists of long answer questions. So in the long answer, they may ask the derivations and theory. So it comes to the long answer. And part C is the short answers. So it is a single line and 2 line answers. Okay. So coming to the part A, problem solving and critical thinking questions. So what are the first one? Find the instantaneous frequency in hertz of each of the following at 40 seconds. So they given 2 signals. So by using these 2 signals, you go to find the instantaneous frequency. So what is the formula for instantaneous frequency? Okay. So first we go to write the given equation. X of t is equal to 10 cos 20 pi t plus pi t square. Okay, 20 pi t square. This is 1. So this is the second one. Okay, no problem. So this is the second b bit. X of t is equal to 10 cos 20 pi t plus pi t square. So here theta of t is equal to 20 pi t plus pi t square. So instantaneous frequency is represented as Fi. That is equal to 1 by 2 pi d by dt of theta t, this one. So here theta of t is 20 pi t plus pi t square. So 1 by 2 pi d by dt of 20 pi t plus pi t square. Okay. So 1 by 2 pi of, so d by dt of 20 pi t. So you get here 20 pi plus t square. T square is 2t. So 2 pi t, this one. So in the denominator having 2 pi. So here 10 plus t. The instance frequency is 10 plus t hertz. Why? Instance frequency in hertz, they ask. So here at a time t equal to 40. So t equal to 40, my instance frequency is 50 hertz. So this is the second one. So coming to the a bit, x of t is equal to 10 cos 200 pi t plus pi by 3. This one. So here theta of t is equal to 200 pi t plus pi by 3. So what is my instance frequency? Fi is equal to 1 by d by dt of theta of t. So 1 by 2 pi again d by dt of 200 pi t plus pi by 3. Pi by 3. So here only single theta. So 20 pi 200 pi. Whereas coming to the second part, pi by 3, second term, there is no theta. So it is treated as constant. So derivative of a constant term is 0. So simply having 20 pi, 200 pi. So this pi is going to cancel and 100 times. So Fi is 100 hertz. So this is the second bit. Okay. Coming to the second one. Calculate the maximum deviation. What is the modulation index when the modulating frequency is reduced to 250 Hz and the modulating voltage is simultaneously raised to 3.2 volts. When the modulating frequencies in an FM system is 400 Hz and the modulating voltage is 2.4, the modulation index is 60. Okay. So first you go to write what is given. FM is 400 Hz, AM 2.4 volts, modulation index 60 beta. So this is a frequency modulation. So use another term. Whereas in amplitude modulation we use mu or small m, but in a frequency modulation we use beta term for representing the modulation index. So beta is equal to delta f by fm. What is delta f? Frequency deviation. Fm is signal frequency, modulating signal frequency. Okay. So this can be written as kf am divided by fm also. Beta you can written as delta f by fm or kf into am by fm. Okay. So kf is equal to beta into fm divided by am. So the given here beta value you know, fm value you know, am value you know. So now we go to substitute. Kf is equal to beta fm by am, that is equal to beta 60 into 400 divided by 2.4. Use 10,000. By using calci you can find. Okay. So this is a kf. So fm is reduced to 250 Hz and am is 3.2 volts. Now what is delta f? So kf am. So what is kf? 10,000 into am. 3.2 is 32,000. Okay. This is delta f. Now What is beta? Delta F by Fm. So 32,000 divided by Fm is 250. Then you get 120. So beta value is 120. Coming to the problem. Here my modulating frequency is reduced to 250. At the same time, this modulating voltage is raised. Initially it is 2.4 volts. Now it is raised to 3.2. Okay. Whereas signal frequency is reduced to 250 Hz. Now what is the beta value? They ask. Initially it is 60. So finally what is beta value? So we got beta value is 128. Understand? So coming to the third one. A single tone FM is represented by the equation V of t is equal to 12 cos 6 into 10 power 8 plus 5 sin 1250 t. This is the FM signal. So determine the following: carrier frequency, modulation index, modulating frequency, maximum deviation, power dissipation in 10 ohm resistor. Okay, very good. So first the given V is 12 sin 6 into 10 power t plus 5 sin 1250 t. So this is given. Okay. So now standard FM modulated signal S of t AC cos 2 pi FCT plus beta sin 2 pi FM t, this one. So you had out the given in sinusoidal you are showing as a cosine. So there is no difference between sine and cosine, only the phase difference. Okay, let's say some phase is difference between sinusoidal and cosine functions. Okay, so you can use this one. Now comparing the given equation with the standard equation. So the below one is the standard equation, the above one is the given equation. So after comparing these two, my AC is 12. Okay, AC is 12. Now 2 pi FC carrier frequency is 6 into 10 power 8. So my FC is equal to 6 into 10 power 8 divided by 2 pi is equal to 95.54 megahertz. Another comparison is beta. So beta is 5 directly. And again, modulating signal frequency 2 pi FM is equal to 1250. So FM is equal to 1250 divided by 2 pi, that equal to 199 hertz. And another one, they ask deviation, frequency deviation, maximum frequency deviation, delta F is equal to beta into FM. So 5 into 199 is gives 995 hertz. Okay, so this is the solution for the given one. Now the fourth one. For an FM modulator with the modulating signal, M of t is equal to Vm sin 300 into 10 cube t. The carrier signal is Vc of t is equal to 8 sin 6.5 into 10 power 6 t, and the carrier, and the modulator index is to find out the significant sideband frequencies and the amplitudes. Okay, so here they given beta. Beta value is 2, modulator index or modulation index, what it may be. And we are going to compare message signal. Message signal contains message signal frequency. So 2 pi FM is compared with 300 into kilo, 300 kilo. So we are getting FM is 47.7 kilohertz. Now, carrier frequency omega c is equal to 2 pi fc, that is 6.5 10 power 6. Fc is equal to 1 mega, 1.03 megahertz. Okay, so USB is equal to FM plus Fc. So FM, here 1.03 into 10 power 6 plus Fc, that is Fc value. FM value is 47.7 kilo. 7 kilo hertz. This is upper sideband. And lower 1.03 into 10 power 6 minus 47.7 kilo hertz. Okay. So after getting my upper sideband frequency is 1.07 megahertz and lower sideband is 98.67 kilohertz. So you know the formula FUSB. Okay. Fc plus Fm, Fc minus Fm. Amplitude is equal to beta AC by 2. You know the beta value, AC value. Finally, it is 8 volts. Okay. So this is solution for the given problem. And coming to the fifth one. So compute the bandwidth requirement for the transmission of FM signal having a frequency deviation of 750 kHz and an audio bandwidth of 10 kHz. If it is an FM radio signal has a frequency deviation of 30 kHz, the modulating frequency is 3 kHz. Calculate the bandwidth needed for the link. What will be the bandwidth if the deviation is reduced to 15 kHz? Okay. So delta F, given delta F is equal to 75 kHz and FM is equal to 15 kHz. So the bandwidth is, by using Carson's rule, 2 into 1 plus beta into Fm. So beta is delta F by Fm. So we go to multiply this Fm inside. So 2 into delta F plus Fm. So we know the delta F and Fm value. Okay. So we got this 170 kilohertz. Okay. So I think this is 50. So 180. So 180 kilohertz. So that is the bandwidth. And another one is delta F is 30 kilohertz. FM is 3 kilohertz. So the bandwidth is 2 into delta F plus FM. So here the formula is same. Okay. So delta F is 30 kilohertz plus FM is 3. So finally the bandwidth is 66 kilohertz. Similarly, delta F1 is reduced. That means the frequency deviation is reduced to 15 kilohertz. So now the new value of delta F is 15 kilo. So 15 plus 3. So 18 into 2. So 36 kilohertz is the new bandwidth after frequency deviation is reduced. Here the FM is same. FM is not changing. So FM is 3 kilohertz. Yes. So this is the second part. Here in this given problem having 2 parts. So the second part here. Okay. So in the second part, frequency is same. But the frequency deviation is reducing half. So now what is the bandwidth? So the bandwidth is also reduced. When frequency deviation is reduced, bandwidth also reduced. So we can conclude from this problem. So the conclusion is when the frequency deviation is reduced, the bandwidth also reduces. Okay. Now the sixth one, an angle modulated signal has the form V of t is equal to 100 cos 2 pi fct plus 4 sin 2000 pi t when fc is equal to 10 megahertz. When fc is equal to 10 megahertz, determine the average transmitted power, and BBT is determine the peak frequency deviation. Okay. So here the average transmit power is PT. So PT is equal to 1 by 2 AC square. So what is AC? Okay, 100. So 100 square. So 10,000 divided by 2. So 5,000 watts. So this is my power, average transmitted power. And peak frequency deviation. So delta F is equal to maximum of 1 by 2 pi into d by dt of 4 sin 2000 pi t. Okay. So here we go derivative, that sine term. So sine we got cos, and inside is 2000 pi t is there. So 2000 pi is coming, not t. So 2000 pi. So 2000 pi into 4, 8000 pi divided by 2 pi. So 4000. Okay. And the maximum, where the cos value is maximum, so it is cos value is maximum value is 1. So here 4000 hertz is the frequency deviation, or 4 kilohertz is the frequency, maximum peak frequency deviation. Okay. Coming to the seventh problem. So here calculate for an angle modulated signal has the form of u of t is equal to 100 cos 2 pi fct plus 4 sin 2 pi fmt, where fc is 10 mega and fm is 1000 Hz or 1 kilo. Assuming that this is an FM signal, determine the modulation index, that is beta, and the transmitted signal bandwidth repeated part A if FM is doubled. So FM second case is 2000 Hz. In the first case, we taken FM as 1000 Hz. So it is 1 kilo. Okay. The second case it is 2 kilo. But FC is same. So first we go to comparing the standard form of FM signal. FM of t is equal to AC cos 2 pi fct plus beta sin 2 pi fmt. So given is 100 cos 2 pi fct plus 4 sin 2 pi fmt. So when compared, AC value is 100 and beta value is 4. So the transmission bandwidth BT is equal to 2 into beta plus 1 FM. So beta value is 4 going to substitute and FM is 1000. So 2 into 5 into 1000. So the transmission bandwidth is 10 kilohertz. Okay. So this is the first case. And second case, if FM is doubled. So FM is doubled means FM is 2 kilo. So my FM is 2 kilo and beta is same. Now the transmission bandwidth is 2 beta plus 1 into FM. So now my transmission bandwidth is 20 kilohertz. 20 kilohertz. Okay. The eighth one is an angle modulation signal is given by S of t is equal to cos of 2 pi into 2 into 10 power 6 t plus 2 pi into 30 sin 150 t plus 2 pi 40 cos 150 t. Find the maximum frequency and phase deviations of S of t. Okay. So here given signal you can treat it as two into 10 power 6 t plus 30 sine 150 t plus 40 cos 150 t. So here you can take common 2 pi. So I'm not writing this 2 pi. Why? In 3 terms we are having 2 pi. Okay. So theta of t is 2 into 10 power 6 t plus 30 sine 2 pi. 30 sine 150 t plus 40 cos 150 t. Okay. So d by dt into theta of t is equal to 2 into 10 power 6 plus 150 square root of, here the amplitude of MOSFET taking, cos of 150 t plus pi. So where pi is equal to tan inverse minus 40 by 30 or minus 4 by 3. Okay, minus 4 by 3. So coming to the next page, d by dt of theta t is equal to 2 into 10 power 6 plus 7500 cos of 150 plus pi. 150 plus pi. Okay. So delta omega is equal to omega I minus omega c, where omega I is equal to d of d theta by dt, where omega c is equal to 2 into 10 power 6. So 500 is equal to 7.5 kilohertz, and the phase deviation is 30 square plus 40 square into 2 pi radians. So 100 pi radians is the phase deviation. So this is the frequency deviation and this is the phase deviation for the given problem. Okay. So last one, in a FM system, a carrier of 100 MHz is modulated by a sensor signal of 5 kHz. The bandwidth by Carson's approximation is 1 MHz. If y of t is equal to modulated waveform to the power of 3, then calculate by using Carson's approximation the bandwidth of y of t and the spacing of spectral components respectively. So for this, FMT is equal to AC cos of 2 pi FCT plus beta sine 2 pi FMT. Okay, so this is the standard equation. We know that M of t is equal to AM cos 2 pi FMT, where beta is equal to delta F by Fm. We can write Kf Am by Fm. So these are the required expressions for the solving this problem. Okay. So when FM signal is passing through a frequency n multiplier, its carrier frequency Fc dash equal to n into Fc. Okay, so it passing through a multiplier. So n into Fc. Now beta dash also m kf am by Fm. So here you can written as n delta F by Fm, or simply n beta. Simply n beta. Okay. So delta F dash is a frequency deviation n delta F. So the message signal frequency remains unchanged, but remaining is changing. Okay. So Fm is what is Fm? 5 kilohertz. So it remains unchanged. Now the bandwidth according to the Carson's rule is 2 into delta F plus Fm. 2 into delta F plus Fm. So what is bandwidth? 1 megahertz is equal to 2 into delta F plus Fm, 5 kilo. So delta F nu, that is the new frequency deviation, is equal to 0.495 megahertz. Okay. So new bandwidth is equal to 2 into delta F nu plus Fm. So it is equal to 2 into 3 into 0.495 plus Fm is 5 kilo. So one is in mega, so another is kilo. So we're going to convert this kilo also into mega. So finally 2.98 megahertz, and the bandwidth nu approximately equal to 3 megahertz. Okay. So the content of information is developed by using Simon Hakim, Sanjay Sharma, J.S. Chitodi, and some other textbooks are used to develop. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.